In recent years, Turkey has been increasingly active in strengthening its defense industry. The country no longer wants to be merely a buyer of weapons, but also a producer of modern military technology. Turkey's interest in the Eurofighter Typhoon arose from the urgent need to strengthen its fighter fleet. In the development of the Eurofighter Typhoon, the entire production process began digitally through computer-aided design CAD technology. Engineers used advanced design software such as CATIA and various modern aerospace tools to build a detailed and precise 3D model of the aircraft. The composite materials used generally consist of carbon fiber and lightweight high-strength materials. Automated laser machines work with computerized systems, capable of cutting intricate patterns in seconds without compromising the quality of the materials. Technicians monitor the entire process through a digital control panel to ensure each cut conforms to the predetermined engineering design. The aircraft's mainframe is constructed of lightweight composite materials and high-strength metals to withstand the extreme stresses of supersonic flight. Every joint is inspected repeatedly to ensure quality and safety in accordance with modern aerospace industry standards. The Eurofighter Typhoon wing assembly process is one of the most critical stages in the production of modern fighter aircraft. On the assembly line, technicians and engineers assemble the Eurofighter Typhoon wings using lightweight composite materials and high-strength metals, designed to withstand the extreme stresses of maneuvering in the air. The initial stage begins with the assembly of the main fuselage structure. Technicians use laser measuring tools and precision robots to ensure each part is assembled to extremely fine tolerances. An error of even a few millimeters can impact the aircraft's aerodynamic performance. Once the main structure is complete, the next stage is the installation of the hydraulic system, electronic wiring, radar, mission computer, and electronic warfare systems. Thousands of cables are manually installed by experienced technicians due to the complexity of the Typhoon's avionics system. In the modern fighter aircraft production line, the engine reconditioning process is crucial to ensure optimal engine performance. During testing, the engine roar is particularly loud when the afterburner system is activated. A long flame coming out of the rear of the engine indicates that maximum power is being generated to test the thrust capability and stability of the engine's performance under extreme conditions. The Typhoon is considered an ideal choice due to its high combat capabilities and proven track record in various NATO military operations. In addition to purchasing the aircraft, Turkey is also reportedly interested in obtaining production access, or at least local industrial involvement in the aircraft's assembly and maintenance processes. If this materializes, the Turkish defense industry could benefit from significant technology transfer. While promising, Turkey's chances of participating in Eurofighter Typhoon production are not straightforward. Because the project involves several European countries, sales and technology transfer decisions must be approved by all consortium members. Political factors pose a major challenge. Turkey's relations with several European countries are sometimes tense, particularly regarding geopolitical issues and regional policies. Furthermore, the technology used in the Eurofighter Typhoon is highly sensitive. Manufacturers will naturally be cautious before granting production access to outside parties. Turkey must also demonstrate that its defense industry is capable of meeting the high manufacturing standards required for modern fighter jet production. Despite the challenges, Turkey has demonstrated significant progress in its domestic defense industry. Companies such as Turkish Aerospace Industries have successfully developed their own combat drones, helicopters, and even fifth-generation fighter jets. These capabilities have led many observers to believe that Turkey has the technical capacity to participate in component production or maintenance for the future Eurofighter Typhoon. If this collaboration materializes, Turkey could become one of the largest military aerospace industrial hubs in the Eurasian region. Even as the world enters the era of fifth and sixth generation fighter jets, the Eurofighter Typhoon remains highly relevant. Modernization efforts are ongoing, including improvements to the AESA radar, the integration of new generation missiles, and the development of more advanced electronic warfare systems. The Typhoon's superiority in air combat makes it a highly sought-after aircraft, with lower operational costs than some fifth-generation stealth jets. The Typhoon still has a strong export market. The world now awaits whether Turkey will truly be part of the future of the Eurofighter Typhoon. If a production agreement is reached, it could transform the regional defense industry landscape and strengthen Turkey's position as a key player in modern military technology. The Eurofighter Typhoon is one of the most advanced modern fighter jets currently in service with several European nations. The aircraft is the result of a multinational collaboration between the United Kingdom, Germany, Italy, and Spain, designed to meet the demands of modern air combat with high flexibility. The Eurofighter Typhoon utilizes a canard delta wing design that provides an ideal combination of agility, speed, and stability. This structure makes it highly superior in dogfights, close quarters combat, while remaining efficient at high-speed flight. The aircraft is capable of reaching speeds exceeding Mach to twice the speed of sound, and has limited supercruise capability, which means flying supersonic without afterburners under certain conditions. This makes it more fuel efficient and less thermally detectable in some scenarios. One of the Eurofighter Typhoon's main strengths lies in its highly advanced avionics system. The aircraft is equipped with the CAPTOR-M radar in early versions and the CAPTOR-E AESA radar in later versions. This AESA radar enables long-range target detection, simultaneous tracking of multiple targets, and resistance to electronic jamming. In addition, the Typhoon also features a combined sensor system called sensor fusion, which integrates data from radar, infrared sensors, and threat warning systems into a single situational display for the pilot. This significantly improves battlefield awareness. The Eurofighter Typhoon is designed as a multi-role aircraft, meaning it can carry a variety of missions, such as air superiority, ground attack, and reconnaissance. Some of the weapons it can carry include long-range air-to-air missiles, like the Meteor, medium-range missiles like the AMRAAM, short-range missiles like the Iris-T or ASRAAM, and precision-guided ground attack, smart bombs. With this diverse arsenal, the Typhoon can adapt quickly to various combat situations.